We're going to cover the volume of prisms and cylinders today. So the goal is that you will be able to apply these formulas in order to help you find the volume of prisms or cylinders. So the volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fit the interior. So basically what that means is if you had a little cube that was an inch by an inch by an inch, so an inch long, tall, and wide. If you had a bunch of these cubes, how many would you need to fill up, let's say, a cylinder or rectangular prism? And obviously, rather than having to actually draw it out, we just do the math for it because it makes it a little bit easier. So the first thing that we're going to start with is just understanding that with a prism, even if it's kind of slanted, it's still going to have the same volume. So Cavalieri is the one that found this, but this principle says that if two three-dimensional figures have the same height and the same cross-sectional area at every level, then they will have the same volume. So all that means for you is when you have a right rectangular or triangular prism like this one on the left, is the volume of that is going to be exactly the same as this one on the right. Even though the one on the right is an oblique prism, because their area is the same throughout, their volume is going to be the same. And another important thing with this is that an oblique prism is basically just a prism that's kind of slanted. But again, in order for this to work, they have to have the same base and the same height. And normally, all that means is that if you're given an oblique prism to find the volume of, you just pretend that it's a regular straight up and down one. So for volume of prisms, there's one main basic formula, and that is the base area B times the height. So volume is base area times height. And if you think you might forget what the big B is, you can also just write it out here. I know for me it makes it a little bit easier just to write what things are in my own handwriting rather than trying to reread sentences. So then for rectangular prisms and cubes, you can still use the volume equals base area times height. But another way of looking at with a rectangular prism is that is length times width times height, because if I wanted to find my base area of a rectangle, I would need length times width. And so my base area is length times width and then times height. If I was given a cube, my base area in this case would be this side times this side. So that would be like side squared. And then you have it, times the third side. So even though the formulas look slightly different, it's still the same basis that it is your base area times the height. So starting off with a straightforward one, we just have a regular, rectangular prism. So looking at this, B is our base area. And even though we are used to writing A equals length times width and all of that, if it makes it easier, you can just use your big B. My base area is length times width. Well, in this case, my length is 13 and my width is 3. So 13 times 3 is 39. So we have our base area is 39 centimeters squared. And then my height is 5 centimeters. So then if I want my volume, I have volume equals base area times height. So volume equals 39 times 5. And 39 times 5 is 195 centimeters cubed. Okay. Now, for this one, we have a volume of a cube with an edge length of 15. So if it makes it easier for you, you can draw yourself a little picture. You don't have to, but I know some people like to label it. Makes it a little bit easier. So we have our cube that is 15 inches on every edge. And remember, an edge is basically where the two faces meet. So there's a bunch of them. So in order to find the base area and this volume of a cube, you can either use that side cubed, or you can say that your base area is length times width. And in this case, that would be 15 times 15. And so your base area would be 225 inches squared. And then your height is also going to be 15. So we have 15 inches. So when we do volume, volume equals base area times height. So 225 times 15. And when you do that, you get that volume is 3,375 inches cubed. Now, if you had used the other formula, volume equals side cubed, you would have volume equals 15 cubed, and then that'll give you the same answer. So finding the volume of prisms can be slightly more complicated because you might have to do some extra work in order to be able to solve this. So looking at this, we have a hexagonal prism. And in order to find the base area, remember that the base area is your apothem times the perimeter divided by 2. So if I want to find that base area, I have to know what the apothem is. And the problem is I don't know what that is right now. I do know that one side of my hexagon is 9 feet. And so what you do is we will draw a little hexagon. And remember, the apothem is always smack dab in the middle. Oops. And so that's what we're going to solve for. So in this instance, we're going to have to use some trig. So I'm going to redraw this triangle a little bit bigger. Oops. Just so you can see where it comes from and why. So with this triangle, in order to find the angle of the top part, we have to do 360 divided by the number of sides. So in this case, that'd be 6. And then 360 divided by 6 is 60 degrees. But then, because I'm really just looking at this little angle in here, I'm going to take that 60 degrees and divide by 2. And that would give me 30 degrees. So now I know that that little angle right here is 30 degrees. So now, in order to do this, I also have to be able to identify one of my sides before I can do trig. And the easiest way is that we have 9 feet right here. So if that entire side is 9 feet, if I'm only going halfway, then that would be 4.5 feet. So I now have my opposite and I have an adjacent that I'm looking for. So that would be tangent. So I have tangent of 30 degrees equals opposite, which is 4.5, divided by adjacent, which I'm just going to put as A. We have to multiply by A to cancel it out. So we have A times tangent 30 equals 4.5. And then to get the A by itself, we have to divide by tangent of 30. So then your adjacent, or your apothem, is 4.5 divided by tangent of 30, which is 7.794. And I'm going to go out a few extra decimal places just to help with rounding issues. Honestly, what's going to happen is on my graphing calculator, I'm going to keep the value that's there, and I'm just going to use it to and just like automatically go into the multiplication. So this right here is your apothem. And so it might help you if you just kind of note that this is your apothem so that you don't forget. So coming back to the base area formula, remember we needed to find this so that we could plug it in to the formula. So my base area is going to be 7.794 times my perimeter, which my perimeter is, I have 9 foot long sides and there's 6 of them. So 9 times 6 is 54. And all this is going to be divided by 2. So again, on my calculator, I have not cleared it. I'm just going to go straight from the answer I have, and I'm using a graphing calculator. So if you have a regular one or a regular scientific, this might not work, but I'm just going to hit times 54 divided by 2. And that gives me 210.44. Now, if you did type in 7.794 times 54 and divided by 2, you would get 210.438, so it is pretty much the same. So we know our base area is now 210.44. So then to find my height, it's given to me. That's my height. And for some of you, you may prefer to tell me what height is first because you know what it is. So now that I have my base area and my height, I'm going to have to plug in to the formula for volume. So I have volume equals base area times height. So 210.44 times 12. And that gives me times 12. That the volume, let me scoot a little bit, is 2,525.33. So because that hundredths place is a 3, I'm just going to keep the 3 that's in the tenths. And this is feet cubed. Okay, so just remember when you have ones that have polygons, you have to use this formula, and oftentimes you're probably going to have to do some of the trig, and that's this stuff over here. Okay. So, Capillaries Principle that we talked about earlier, saying that a regular straight up and down prism is the same as a slanty prism. This is actually the same for cylinders as well. And so just like other prisms, the volume for a cylinder is volume equals base area times height, or if you prefer, volume equals pi r squared times height. And if you notice, all they did was replace that base height with the actual formula for an area of a circle. So if I want to find the volume of this cylinder, to find my base area, I'm going to have to do pi r squared, which in this case, my radius is half of my diameter. So my radius is 9. So we have pi times 9 squared equals 81 pi. Now, even though the question says to give it in terms of pi and round to the nearest tenth, I'm actually just going to leave my base area as 81 pi because I really don't need that decimal form until I'm at my final answer. So then for this, even though the cylinder is slanty, its height is 14 inches. And so we're still going to plug into the formula like we were before. So volume equals base area times height. My base area was 81 pi, and my height is 14. So then 81 times 14 is 1,134, and this is inches cubed. Ooh, actually, no. Ooh, almost forgot the pi. So 81 times 14 is 1,134 pi. But remember, we have that, or we put it in terms of as a decimal. So then you do 1,134 times pi, and that gives you 3,562.566. And so if we have 0.566 rounded to the nearest tenth, this is our tenth. That 6 tells me to go up, so it's actually going to be 3,562.6 inches cubed. Okay, so again, remember, you can leave it in terms of pi until the end. Leave in terms of pi till the end. All right, so we have a volume now of a cylinder with a base area of 121 centimeters squared and a height equal to twice the radius. We're going to give our answer in terms of pi and round to the nearest tenth. So what we know right now is that our base area is 121 pi. So I'm just going to go ahead and fill it in, 121 pi. And then my height, the only thing I know about my height is that my height is double my radius. So in order to do this, my base area is going to have to be used because the area of a circle is pi r squared. So if I plug in my base area of 121 pi, when I solve this, I can solve for r. So I divide by pi. Oops. so that they all cancel out. And I have 121 equals r squared. So you take the square root of both sides, and r equals 11. Okay? Or sorry, r equals 11. Ooh. So because my height is double the radius, I would have height equals 2 times 11, which is 22. And this is centimeters squared. So if I want to find the volume of this, I'm going to have volume equals base area times height. So that is 121 pi times 22. And that gives you volume is 2,662 pi. Or, remember this is in terms of tenths, that times pi is 8,362.91. And so the 1 tells you to just keep the 9. And this is centimeters cubed. All right, so finding the volume of composite shapes or figures with 3D is basically the same as when you do it for anything else. We have two different major shapes, and we're going to find the volume of each of them and then just add them together. So volume, sum of the volumes of the individual figures. So I'm going to start with the rectangular prism because I feel like it might be slightly easier. So with the rectangular prism, we're just looking at this bottom piece right here. So in order to find that, we need volume equals base area times height. In this case, my base area is 8 times 4 because it's this side times this side. And then my height is 5. So my volume, 8 times 4 times 5, is 160 centimeters cubed. So then, to find the area of the triangular prism, we're going to have to do some extra work because in order to do the base area, I'm going to need the base of my triangle times its height divided by 2 times height. And so because there's two heights, for some of you it might be easier if you fill in what the height of the prism is first. So with this, because this triangle is my base, even though it's not sitting on it, that means that this other side here is my height. And so if that's my height for the prism, then that means that 4 is the height of this prism. So looking at this formula, in order to fill out that base times height divided by 2, I'm going to need the base of my triangle. Well, the base of my triangle is this side right here, which is the same as this side. So that's going to be 8. And then to find my height, I'm going to have to actually look at the triangle itself. So I'm going to come down here for a moment. We have 8 and 8. In order to find the height, we're going to have to come up the middle. And if you notice, that gives me a right triangle. And since I came up the middle, I know that this is 4 and this is 4. So looking at just this triangle on the left, I have two sides that I know and one that I don't. So I can use Pythagorean Theorem to help me. So 4 squared plus b squared technically, because I'm looking for h, I'm going to use h squared equals 8 squared. So then we have 16 plus h squared equals 64. And 64 minus 16 is 48. So when we take the square root of both sides, we get that the h, or height, is 6.928. And I'm just going to leave it as decimal just for rounding purposes. So 6.928. So now that I have that in, now I'm just multiplying. So that number times 8 times 4 divided by 2. And that gives you 110.85. For rounding to the nearest tenth, that 5 tells me to go up, so it's going to be 110.9. And that is centimeters cubed. So then, because this is a composite shape and it's these two shapes together, we are going to add 160 and 110. So the volume of this is actually 160 plus 110.9. So the volume of this composite shape is 270.9 centimeters cubed. Okay. So find the volume of these figures. I would recommend pausing the video and just trying to do it on your own. But for this right rectangular prism, if you want to draw a picture, always a good idea. So we have a rectangular prism, and we have a length of 14 centimeters, a width of 11 centimeters, and a height of 18 centimeters. So because we're doing volume, it's still the base area times the height. And in this case, the base area would be 14 times 11 because it's length times width. And then it's getting multiplied to that 18 so that we can get the third dimension. So 14 times 11 times 18 gives me 2,772, and this is centimeters cubed. Okay. For number 2, it is a cube. So if I draw myself a cute little cube, each side is 22 feet. So that's 22, and that's 22. Oops. So using the formula, base area times height, my base area is 22 times 22, and my height is 22. Notice I have 3 22s. I could have also used that volume equals side cubed. But 22 times 22 times 22 gives you 10,648 feet cubed. Oops. Okay. With this hexagonal prism with the base edge length of 10 feet, for me, it is always easier if I draw some pictures. So this I know is 10 feet, and I'm going to have my apothem that comes down, and that little slice that I can take out of there from that with that apothem. So, sorry, I had to yawn. So when you're doing this, we have to use trig again because we have to find the area of our base, and the only way to do that is to have the apothem times the perimeter divided by 2 times the height. So looking at this, I'm going to draw the small slice a little bit bigger. In order to find the angle measure, I have to do 360 divided by 6 because there's 6 sides. So that gives you 60 degrees, and that is for the entire angle. So if I just want this little baby angle, I'm going to divide by 2 and make it 30 degrees. So then, because each side length is 10 feet, I know that half of that is 5 feet. And then I'm trying to find the apothem, so I'm just going to label it as A. So remember, it's almost like I'm just cutting this slice out and bringing it up. So when we do this, we need to find our apothem. So we have opposite and adjacent. So that would give me tangent of 30 equals opposite, which is 5, over adjacent, which is just A. So then we multiply both sides by A to cancel it out. So we have A times tangent of 30 equals 5, and then we divide by tangent of 30. So that we have that the apothem is 5 divided by tangent of 30, which is 8.660. Again, if you need to, this is our apothem, and it might not hurt you to just write it out so that you actually know what it is. So, plugging into the volume formula, we have volume equals, the apothem is 8.660 times the perimeter, which the perimeter is, there's 6 sides, all 10 feet, so that is 60. And then it's getting divided by 2 and multiplied to the height, which is also 10. So then 8.66 times 60 divided by 2 times 10 gives us 2,598.07. And at 0.07, this tells us to round up, so this is going to be 0.1. An easy way to think about rounding too is if, let's say, you're trying to figure out, like, should you round up or down with 0.7? Think of that as like 7 cents. If I had 7 cents and I wanted the nearest tens, the closest 10 would be 10, so that'd be 0.1. And the label for this would be feet cubed. So last but not least is a cylinder. So if you want to draw a picture, you draw an oval. Then from the edges of your oval, you just go down. And then you just make a little curvy line at the bottom. And if you want, you can even continue it out through the back. Kind of up to you. But with this cylinder, I know that the diameter, so all the way across, is 16 inches. And I also know that it has a height of 7 inches. So if I want to plug into the volume formula, I need the area of my base, which is pi r squared. And in this case, r is half of that 16 because that's a diameter. So r is actually just 8 inches. And then my height is 7 inches. So then 8 squared times 7 gives us 448 pi. Or if we multiply that by pi, 1,407.43. And in this case, they said they don't need the answer in terms of pi. And let me just double check the top. Yep, rounded nearest tenth. So you don't have to even have the 448 pi. For me, I would probably just put it, but that's just personal preference. And this is inches cubed. So hopefully this was helpful. If you do not have the 11.2 homework worksheet, be sure to send me an email or get a hold of me. If you have any questions, feel free to ask at your earliest convenience.